BPDU Guard protects against one of the biggest dangers with spanning tree, rogue switches. In this video, we'll talk about BPDU Guard in two cases, when you're not using PortFast and when you are using PortFast. Let's jump in. So BPDU Guard, as usual, I like these videos to follow the outline of the book, but in this case, I've got BPDU Guard topics in both chapters 9 and 10 of the current CCNA Official Cert Guide, Volume 1. So what's up with that? Well, it turns out I put the concepts in Chapter 9, but without config, and the config and verification steps in Chapter 10. And I did that on purpose in the books, just to match up what the book was doing. But for this video, I'd like to put them together. So I've located the video with Chapter 10 in the video course outline. And I put all the BPDU Guard concepts here in this one video. So here's the video outline. I've got the concepts, the basics here in the first section. And then we'll get into the config and verification in the middle three. We'll see how to configure it along with PortFast, which is very popular here at the beginning. We'll talk about global config. It's kind of a tangential topic. Then configuring on trunk ports, which is basically the same way, just to clarify how to configure that. And then we'll close talking about the PortFast loop danger that occurs and how when we team that up with BPDU Guard, how it changes the logic there. As usual, if you hang around till the end of the video, we'll act like we're in the same study group together, and I'll give you advice about what to do with this topic once you're done with this video. In particular, I'll point you to a review activity here at the channel. It's an interview review video. It's a great study tool. And then I'll talk about what you can get out of the book and how to review from there as well. All right, let's get into BPDU Guard. First, the big ideas. Imagine a typical LAN. You've got these 4 switches, and they're going to send hello messages. Now, I'm not showing which switch becomes the root switch, but one of them is, and it sends hellos, and the others forward, or on the hello timer, they forward these BPDUs. So we expect BPDUs in different directions on all these links between switches. All right, that's normal. But out there on the edge, in the bottom of this diagram, the BPDUs flow in one direction. They flow from the switch toward the endpoints. The endpoints ignore them because the endpoints aren't using spanning tree. And the endpoints don't send any BPDUs into the switches, right? So it's one-way flow of BPDUs. Now, given that, think about switch A1 down here, an access layer switch that's connected to some of those endpoints. I'm going to focus on that one for a moment. So here's A1 again. It may be getting BPDUs coming in. We're thinking and focusing about incoming BPDUs into the switch. So it may be receiving BPDUs in from those other switches, but it should never be receiving any BPDUs from those endpoints. All right, so I'm being, very picky about that. But by design, based on how I've built this network, we should never have A1 receive BPDUs on those access ports, right? So what BPDU Guard does for us is this. It monitors those ports, and if BPDUs arrive, it acts. And it disables those ports because, hey, we shouldn't receive those. That means somebody's plugged in a switch they shouldn't have. We want to react to that and make that port unusable. So where do we want to implement this feature? Well, we want to implement it out there at the access ports where we should never receive a BPDU. If you do receive a BPDU on those ports from A1 and A2's perspective, somebody has broken the design, they've unplugged a PC, they plugged in a switch, and we definitely don't want to implement BPDU Guard up here because we expect BPDUs to be sent up there. This next slide is a great study slide because it summarizes all the BPDU Guard logic, all right? But let me talk you through it. First off, access switches don't receive BPDUs from endpoints, as we've been talking about. So the switch on those ports will monitor for incoming BPDUs, and if it receives a BPDU on any of those ports, it'll disable the port. But there's more detail than that. So it disables the port and places it in this new state we've not talked about in the sequence of the course, at least. This state is called error disabled. So here's what I want you to think about. We've talked about other ways for a port to be down. We've talked about the physically down, if you will, where a show interfaces shows the port is down and down, or show interfaces status as not connect. And that would happen if there's no cable installed, or if it's a bad cable or the other device is powered off. And we've seen administratively down when we type the shutdown command in config mode for the interface. Well, this is a new way to do it. And error disabled might might be better described as software disabled, where a software process on the switch decides, hey, I want that port to not be usable. So it's down, but it's because of a software choice. In this case, the software is this BPDU Guard feature. So the software says, hey, stop using this port. It's error disabled. And because the port is down in that sense, it's totally removed from the spanning tree protocol topology. It's just not there anymore. Show commands about spanning tree won't list that port anymore. So now that it's down, the engineer can notice that it's down and do something about it, like investigate who plugged in the rogue switch. To recover that port, the engineer, by default at least, the engineer needs to get into config mode, shut down the port to administratively disable it, and then no shut down the port to bring it back up. That recovers it. You can add additional configuration, though, that says, hey, when a port gets error disabled, wait 15 minutes and then bring it back up automatically if that's your preference, all right? But we're not going to get into that particular option. We'll just use the shutdown, no shutdown option to recover it. To hit the highlights of the implementation, to enable BPDU Guard on an interface with an interface subcommand, you get into the interface's config mode and type spanning tree BPDU Guard enable. Enabling the feature, it's off by default, so that enables it. If you want to revert back to the default of not using BPDU Guard, you've got two options, and you see those down here. Spanning tree BPDU Guard disable or no with the same command. No spanning tree BPDU Guard enable. So both of those disable BPDU Guard. Then if you want to see it working, well, the most obvious commands don't mention BPDU Guard as it turns out. So show spanning tree interface, whatever, in this case gig 1011. It lists spanning tree information. It just doesn't say anything about BPDU Guard. Show interfaces does not say anything about BPDU Guard. What you need is the show spanning tree command with the detail keyword. So show spanning tree for the interface with the detail keyword. If you look far enough, you'll see a line that says BPDU Guard is enabled that confirms that it is indeed enabled. As it turns out, BPDU Guard is very popular to use with PortFast. So let's review PortFast for a moment. You've got an access port, you've got some endpoints connected to it, and it turns out with spanning tree rules, it's going to converge and choose those access ports to be designated ports. They will eventually reach a forwarding state. But without PortFast, it takes time to reach a forwarding state. With plain old spanning tree, that convergence to get from choosing designated port to reach a forwarding state takes 30 seconds. It doesn't take quite as long with RSTP, but it takes seconds to get there. Enabling PortFast makes that a sub-second convergence. As soon as the switch decides that these ports are designated ports, it places the ports in a forwarding state. But turns out using PortFast and PortFast alone does create a small danger. So just to review that, if you've got, say, a couple of ports that are connected up to endpoints and you enable PortFast, and then somebody comes along and places one of those rogue switches out there, it can create a forwarding loop. Now, in case number one here, there's no possibility of a loop because there's no physical path for frames to loop around. Case number two, we replaced two PCs with two rogue switches, but there's no path for frames to loop around. It's when you replace multiple switches and connect them together, as you see here, that there's a path for frames to loop. That's when, with PortFast and PortFast alone enabled, it's possible that for a short period of time that a loop would occur and lots of frames would get forwarded into the network repeatedly. PortFast, what it does when it recognizes that these rogue switches are attached, it disables PortFast and it reconverges, and in this case, it's going to block on one of these ports, thwarting the loop, stopping the loop from happening, but during that time of convergence, there can be this forwarding loop. All right, so that's a quick review of PortFast. There's a complete video about PortFast if you want to circle back and watch that. So PortFast has rules to deal with this issue. You don't have to team it up with BPDU Guard. But what happens when you team it up with BPDU Guard is you get different logic in reaction to the receipt of one of those BPDUs. You get BPDU Guard's action. All right? So when everything's great, there are endpoints attached, not rogue switches, and there are no incoming hellos. PortFast is working. We get fast convergence. But it's BPDU Guard that's monitoring for those incoming hellos. Then when somebody attaches a rogue switch and they start to send incoming hellos into the normal switch, it's BPDU Guard that reacts and it error disables the port so that the network engineer can notice that the port's down, look into it, find who turned on the rogue switch, have a conversation, come up with a better solution, not have them turning on rogue switches, so on and so forth. So it's often the much preferred reaction rather than the PortFast native reaction. All right, so just to sum up, with BPDU Guard and PortFast, when those BPDUs arrive, disable the port with error disabled, remove it from the STP topology because the interface is down from a functional perspective, and to recover, we need a shutdown and no shutdown by default. So just looking at the implementation for a moment, if you've configured both PortFast and BPDU Guard on a port like gig 1011, and endpoints are attached, no rogue switches yet, you're going to see the port role, spanning tree role is designated. You'll see the port state as in the forwarding state. If you do a show interfaces status, you'll see the port is connected. Everything's good. Then, if you were to plug in a rogue switch into that port, you'd see some log messages like the ones you see at the top. Say, hey, we received a BPDU on this port that has BPDU Guard enabled. We're disabling the port. And the next message says, hey, we're putting gig 1011 in an error disabled state. And this bottom command down here, show interfaces status, shows us the status is indeed error disabled. So that's a confirmation that we placed the port in error disabled, and it's going to stay there. At least with default settings, it'll stay there until you get into config mode, issue a shutdown command, and then a no shutdown command to recover it. Imagine this access switch typically just has a couple of uplinks to other switches like these, where you wouldn't want to use BPDU Guard, but most of the ports on an access switch like these are connected to endpoints, and that's where you do want to use BPDU Guard. And honestly, it's most often a combination of PortFast plus BPDU Guard. So there's a very convenient way to enable BPDU Guard with PortFast without a lot of config commands. And here it is. What you do is you add this one global command, spanning tree PortFast BPDU Guard default, which means this: enable on PortFast enabled ports the BPDU Guard feature by default. So there's your logic. If a port has PortFast enabled via other config, also enable BPDU Guard by default. Now, if you stop there and ignore this other bit of config, there you go. If the port is running PortFast, it's now also running BPDU Guard. Now, let's just say you did that and you had those 24 ports that are connected to endpoints, and you enabled PortFast there, great, but what if there was one port you didn't want to use BPDU Guard on? How do you overcome that? With this extra config. You get into interface config mode for that one port, and you'd issue a command like this, spanning tree BPDU Guard disable, which then overrides our new default to use it. All right, so that's the combination there. To be complete, I want to cover one other variation on the configuration. So imagine we've got these servers and then these ports with phones and PCs on them like you see down here. Well, to enable BPDU Guard on those ports, you can do that because there are no switches down here and there's no physical loops occurring down there. So you can enable BPDU Guard. None of these devices will be sending in BPDU Guard. So you can enable BPDU Guard down there on these ports on the switches, all right? There's no difference in the config down there. You definitely don't want to enable it up here on the ports connected to other switches because we do expect to get BPDUs from those. So what's the config look like? Well, there's no difference in the interface subcommands. Here's the spanning tree BPDU Guard enable command, and that's on the port that say is connected to a server that's using trunking. There's no special keywords. There's no mention of the word trunk. It's the same exact command we would use per the description on a port that's connected to a phone. And it's the same exact command that would be used on a port that's connected to a single end user device like a PC. So why do I go to the effort to tell you, hey, there's no difference in the subcommand to enable BPDU Guard? You may not remember, but PortFast, there is a difference. On ports that are connected to a server that's using trunking, we would configure spanning tree PortFast trunk to enable PortFast, whereas in the other two types of port, we don't use that trunk keyword. So there is a difference, with the PortFast interface config. There is not a difference with the BPDU Guard interface config. We've talked a few times here about the danger with PortFast, that if we replace endpoints with rogue switches, that there can be a forwarding loop. So PortFast has ways to deal with that itself, where a temporary loop happens, but PortFast will fix that by reverting to using spanning tree. And in this video, we've talked about how we can team PortFast with BPDU Guard. It takes a different approach where BPDU Guard error disables the port in reaction to those incoming BPDUs. There is a third option, and an upcoming video talks about that. It's called BPDU filter. Again, it changes the logic of what happens in reaction to incoming BPDUs. It disables PortFast. It lets spanning tree take over, but with some differences in the detail. I'll leave that discussion for the video about BPDU filter. And just to mention them, there are two other spanning tree protocol small features discussed in CCNA, loop guard and root guard, and those don't have anything to do with teaming up with PortFast, so they're not connected. I do have videos on those as well. So what do you do with this BPDU Guard thing from here? Well, first off, you really should understand PortFast as well. So if you didn't watch that video yet, you definitely want to circle back and watch that. And use the upcoming interview review to practice that. You might even give it a few days before you use that. So what does that interview review have in it? Well, it's got a topology like this. And over here on A1, we're going to talk about things, and I'm going to ask you to explain things as if you're in a technical interview. And I'm going to tell you, hey, you're not using PortFast here. You're just using BPDU Guard over here on these ports. And you are using PortFast along with BPDU Guard on this right-hand access switch A2, and explain that. Additionally, if you've got the books, look for the BPDU Guard topics in both Chapter 9 and Chapter 10. Again, give it a few days and then read those matching sections, different perspective and examples, and that'll help solidify what BPDU Guard does in your head. Thanks for watching the whole video. If you're ready to circle back and learn more about PortFast, click on the left and you'll go directly to that instructional video. If you're ready for that interview review on BPDU Guard, click over on the right. Hey, thanks for spending time with me. We'll talk to you soon.